Good morning, mathematicians. This morning we are going to add and subtract mixed numbers with unlike denominators. Let's go ahead and get our date, our title. Next, we can focus in on our objective. I will ungroup to add and subtract mixed numbers. Read it with me. I will ungroup to add and subtract mixed numbers. This is going to be really crucial for the subtraction end. And when we talk about regrouping, we're going to talk about, let's focus over here on this mixed number. When we look at this mixed number, we can actually break it apart. In our last video, or our last live session, we talked about ungrouping, but as borrowing. So to increase this numerator, to use it to subtract from. So I can borrow from the whole number. And we need to ask ourselves this question. How much is one whole number? What is its value in the fraction? And underneath here, I've rewritten the whole number 6. 6 can be written as 8 over 8 plus 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 8 over 8. So all 6 make up our whole number. So we can actually break this apart. We can borrow. The 6 turns into a 5. So 1, 2, 3, 4, 5 8 over 8s. And then we take the leftover 8 over 8 and we send it out. So we add 5 plus 8 over 8 plus our original fraction, 3/8. And we can rewrite it as 5 and 11/8. So these two numbers have the same value. They're just written differently. But if we're going to subtract from 3/8 and the fraction that we are subtracting from 3/8 is too large, we have to reorganize through ungrouping. And from this point, we can move on. But I want to take a moment and practice ungrouping. So let's take a look at a few fractions or mixed numbers. Let's practice ungrouping. 10 3/4. If we needed to ungroup this, look at the denominator. The denominator's of 4, so my whole numbers. My 10 is equivalent to 4 over 4 plus 4 over 4 plus 4 over 4, and I hope I have enough room. That's 1, 2, 3, 4. I've got 6 more to go. 5, 6, 7, 8, 9, 10. So my 10 is equivalent to all these 4 over 4s. I need to ungroup. Let me take 9 of them. That will become my 9. Then I will take the leftover 4 over 4, 4 over 4, 4/4. Bring it up. 9 plus 4 over 4 is 10. Let's bring in that 3/4. I keep my whole number. I come through and I add these up. What do I get? That's right, the denominator stays 4. What's the new numerator? 7. So 10 3/4 is the same equivalent value as 9 7/4. Let's ungroup another. Remember, the point of ungrouping is to increase this numerator so we can use it to subtract from. Look at the denominator. Each whole number is going to be what? 5 equals, we're going over 8. How many 8/8 will I have? 5 total. One, 2, 3, 4. One more. So remember, I want to decrease my 5 by 1. Turn that into 4. It's represented here. Bring up my 8/8. that makes 5 wholes. 4 plus 1 is 5. And then bring over my 1/8. We end up with 4. 8 plus 1 is 9. 4 9/8. So 4 9/8 is the same as 5 1/8. All right, let's do the last one. I have 3 whole numbers. The denominator is of 6. This one's really easy. So my 3 is equivalent to 6 over 6 plus 6 over 6 plus 6 over 6. And I want to decrease it, so I'm just going to grab 2 of those. 2 plus 6 over 6 plus 4 over 6 equals. Keep the 2, keep the denominator, add your numerators. 4 plus 6, 10. So 3 and 4 6 is equivalent to 2 and 10/6. Now, once you have your mixed number with an improper numerator here, you can go forward and subtract from these numbers. All right, let's take a look at an actual adding and subtracting of mixed numbers question. Let's take a peek at 9 1/6. Minus 5 and 7/9. We need to make sure that this mixed number is big enough that I can subtract an unknown from it. Now, if I look at my fractions here, 1/6 is closer to 0 than it is 1 whole. 7/9 is closer to 1 whole than 0. So I know this is going to be a bigger fraction than this fraction. If you really need to, if you're unsure, if you need to ungroup, just pull the fractions out, compare them. Which one is bigger? 6 times 7 is 42. No. 9 times 1 is 9. So I could say 1/6 is smaller than 7/9. Now, this only works because, get out of here, Winston the cat, getting in my way. If you take your denominators and multiply them together, 9 times 6 is 54. So the equivalent fraction here would be 9 54ths and 42 54ths. So when we do that butterfly method, we're actually taking a shortcut in comparing. So this is smaller, so I'm going to have to borrow. So this is my original problem. First, I got to compare fractions. That's first. And in this problem, I know I have to ungroup. So let me take my 9 1/6. Let's rewrite it. 9 equals, using denominator 6. I'm going to ungroup. I'm going to take 8 of them. Keep 1 whole fraction. I'm going to bring over my 1/6. How can I rewrite it? 8 and what over 6? 6 plus 1 is 7. So now I have a bigger number. So we can compare this number. So I can take 5 from 8. Now I can take this 7/9 from 7/6. But we have to figure out the next step. The next step is equivalent fractions. So first we compared, well, let's call it third. Third is equivalent fractions. Second was ungroup. First compare, second ungroup, third we need equivalent fractions. So let's take our new fraction, our new mixed number, and bring it down. 8/7/6 minus 5/7/9. What we do now is we can go one of two ways. We can separate them and just make an equivalent fraction and rewrite it. Or you could take these mixed numbers and turn them into improper fractions and then get the equivalent fraction. But the number is going to be much bigger. If we start multiplying 6 by 8 and adding 7, we're going to have a really top-heavy improper fraction that we're going to have to figure out by making equivalent. So I'm proposing that for equivalent fractions here, let's separate it. Let's leave our whole numbers alone and just pull out our fractions. 7/6, 7/9. Extend your fraction bars. Look for a multiplier. So I need to increase them both. What is a number that 6 and 9 both have in common? Now, I could use 9 and say 7 times 9 and 6 times 9. I'm going to get a really big number. I definitely have a smaller number that they both align with. So I'm going to use the tried and true method here. I'm going to list their factor or their multiples. So 6, 12, 18, 24, 30. Those are my 6s. Let me go with my 9s. 9, 18. All right, I've already found a number. It's 18. So that's the smallest number they both can be turned into. So how do I go from 6 to 18? I multiply by 1, 2, 3. So the number I will use as a multiplier for 6 is 3. And that will give me 6 times 3 is 18. Now, for 7/9, I also want to end up with 18. Look at my 9. 9 times 1, 9 times 2. So my multiplier is 2. Oops. 7 times 2 is 14. 7 times 3 is 21. Now I have equivalent fractions. My 7/6 is now 21/18, and I can take away 14/18. Now, just to give you guys some perspective, look at how much work we've already done in this problem. So much work. I'm going to rewrite 8 and 21/18, 5 and 14/18, subtract. So now we're on to step 4, we're on to subtract. And I'm going to try to fit this in. I probably should get a new sheet of paper, but I'm going to try to focus in here. My zoom works. Almost kind of sticking. Alright, this is the best we're going to get it. So let's start with our fractions. So step 4, fourth, subtract. We're doing a lot of work to get to subtract. 21 minus 14, 7. Keep the 18. 8 minus 5 is 3. So our answer here is 3 7/8. And we've done a lot of work to get here. Alright? And When you add mixed numbers, it's going to be less important to ungroup to start, but you're probably going to end up starting at step 3 for getting your equivalence. It's going to be much easier. This is going to be the most challenging type of problem that you're going to run into. All right, guys, good luck today. I hope this clarified things for you. I'll see you at the meeting.